As promised, a quick little video on elimination as a problem solving method. So continuing on with the approach we've been taking to try to get rid of possibilities. When you can eliminate things, it makes life a lot easier for you. So let's get going. Your clues, the 6 clues that you have are right here. Now I'm not going to go through every little bit, but I'm going to hopefully get you to a point that you can finish up each of these problems. So again, one of the things you want to look for is the clue that makes the most sense for you, and not necessarily just grabbing the clues in order, because if you just go with the first one, I'm not even, then you still have all of the possible odd numbers. So as you cruise down, I'm greater than 200, I'm not a square, I'm divisible by 5, I'm less than 400. So I think probably B and E are good places to start, because we have I'm greater than 200, less than 400. So you know it's somewhere between 200 and 400. So that helps narrow things down. And if you say I'm not even, so it's only the odd numbers that are within those. And then I'm divisible by 5. That combines very nicely with clue A of I'm not even. So if I'm divisible by 5 and I'm odd, that means that every second one of those, it can't work. So you could have 2005, but you can't have 2010, 210. So 205, you can't have 210 because that's even. So the next one is 215. Then you can't have 220, so you can have 225. You can't have 230, but you can have 235. And you can continue on in this way and really narrow things down, because then you can cross off anything that's a square number, and then I'm divisible by 9. Should really be able to get that list down. So between 200 and 400, has to be an odd number, and then also divisible by 5. So divisible by 5. So this list got pretty small pretty quickly. So 235, then it's 245, 255, 265, 275, 285, and so on. So already we'll be able to get that list down, and then when you start checking off the ones that I am divisible by 9, then you should be on your way. Now there is a divisibility test for 9. If you add up the digits, whatever that total is, if that number is divisible by 9, then the whole number is. So if we look at I don't know, let's take the number 225. So the number 225, 2 plus 2 plus 5 equals 9. 9 is divisible by 9, so that means that this number is also divisible by 9. So if we tested that out the long way, 9 goes into 225, goes in there twice, that's 18. It's a 4, bring down the 5, it goes in 5 times. So 9 times 25 is 225. So that is the quick little divisibility test. Add up the digits, and if that total is divisible by 9, then the number is. So hopefully that'll get you going on the first one. For the second one, Linda received 4 stamps from England, Spain, France, and Italy for her collection. The stamps are not marked, so she does not know which stamp came from which country. A fellow stamp collector gave her the following clues. The French stamp is red, the English stamp has a picture of a castle. So already you might be able to say, all right, this could be the English one. And the white stamp has a picture of a fountain. So there's a fountain. So this one's white. There's a little chart here that might help you sort of figure out which one is which. So you could say, go through the different colors, white, red, blue, green. There you can list the colors, and then when you figure something else out about it, so for instance, the white had a picture of a fountain, so the picture is the fountain. We may not know the country yet, but we will, and we'll be able to figure out the table from there. So we don't know what color the English stamp is, but we do know that's the castle, so we might be able to narrow some things down. So the flower is on the blue stamp. So this one's the flower, that one's blue, so you can put that in. So under blue, the picture is a flower. And just keep plugging away at the different clues. The Spanish stamp is not white, so this one definitely can't be Spanish, this spot right here. So we know that bit. And just by going through, after you've gone through the clues once, you can jump back through them again. And so we're almost halfway done with this, well, we are halfway done with this table. So use those clues, go back through them, and see if you can complete that table. This one's very similar to a problem of the day that we had a little while ago. Old MacDonald was on his way to a market when a case of eggs fell off the back of the truck. Looking at the huge omelet on the road, a man asked how many eggs were in the case. When I counted by twos, there was one left over. When I counted by threes or fours, there was one left over. When I counted by five, there were no eggs left over. If MacDonald had less than 100 eggs in the case, what were the possible numbers of eggs he could have? Again, we have the whole idea of figuring out those clues. So when we counted by twos, there was one left over, or threes or fours. But when we counted by fives, there were no eggs left over. So that means that that number, whatever it happens to be, is a multiple of 5, but it's also less than 100. So you can even start with just the multiples of 5. So 5, 10, 15, 20, 25, 30, and so on. So you get that list, and then go through with your other clues. When 2 goes into it, there's 1 left over. So really anything that ends in a 0, like the number 10, 2 goes into that evenly. So again, we're to the point where we can cross off anything that ends in 0, because that doesn't work with that other clue. So we've already cut things in half. So I think that list is going to get very small very quickly, and then you'll be able to use the 3s and the 4s to really narrow down that list and come up with exactly how many eggs were in the case. And one other, this is, again, it's a sort of deductive reasoning, logic problem. Juanita, Esther, and Grace left school together. In their rush to leave, they mixed up their caps and gloves. Each one wore someone else's cap. That's an important part. Each one wore someone else's cap. And the gloves that belonged to yet another. So the gloves were even someone different. So, in other words, looking at this chart, if Grace had Esther's cap on, she couldn't have had Esther's gloves on. So that's somebody different. So it wasn't Esther, it's not Grace, so here would have to be Juanita. If Grace wore Esther's cap, determines whose cap and whose glove each girl wore. So we already have 2 of them done, and from here you can look and say, all right, well, if Grace wore Esther's cap and Juanita didn't have Esther's on, she couldn't have her own on, really, I think is going to be a pretty easy chart for you to figure out. As soon as you start plugging them in, keeping in mind that each one wore someone else's cap and yet another pair of gloves from one of the other girls. So hopefully you're on your way, and I hope you're enjoying your blizzard bag day. We'll see you tomorrow.